Hey everybody, CBQ here from Greenzie, back with another edition of How It Works, where we explain how our product works, diving into deeper detail to help you understand how to make the most out of autonomous mowing. Now today we'll be talking about what the cameras actually see. The reason it's important is that depth sensing cameras operate similar to lidar or radar in that they see in depth, not like the cameras we're used to looking through like this one that are 2D, flat color images. First, some definitions and a bit on the hardware. Now, on several mowers, including the autonomous standard ZK from Wright Manufacturing, available in limited production as of the time of the publishing of this video through select Wright equipment dealers, the Greenzie autonomous mowing software that runs on top of these uses the Intel RealSense D400 series line of stereo cameras that feature high depth resolution and active infrared or IR stereo with a standard field of view, not a wide. It has a global shutter with an ideal range of 0.6 meters, which is 23 inches, to 6 meters, which is 20 feet. It has an onboard vision processor and an infrared or IR projector. Now, other models we integrate with use lidar radar, but they have similar output. So a stereo camera is a type of camera with 2 or more image sensors, and this allows it to simulate the human binocular vision and therefore gives it the ability to perceive depth. It's worth noting that because we use the depth and not color images, we actually put a polarizing filter that blocks most wavelengths, including most color information. Yes, you heard that right. We don't use color imagery. So if you were to look through the cameras, which again, we don't use in our pipeline, everything has a purple tint to it. Now, the output of these cameras is a depth cloud. A depth cloud, or point cloud as it's often referred to, is a set of data points in space. The points may represent a 3D shape or object, but each point has a position in a set of Cartesian coordinates. Oftentimes, we visualize them to a 2D color image by converting them to a depth map, which might show red as far away and blue as close. But again, this is another visualization tool just for us humans to see. So since the mower actually sees in depth, the first pass of the data is very noisy. The depth cloud itself can be output up to 90 frames per second at a very high resolution and contains many points. You can imagine what happens if it rains. You'll see lots of depth information, so it's actually too much to process and utilize. Since our system takes raw depth information from many cameras on this Wright autonomous standard ZK, it's 4, we utilize a very fast pipeline in C++ to take that depth cloud and convert it to actionable information. The first thing we do is voxelize it, which is the process of converting the data structures that store that geometric information in some domain, such as a 3D depth cloud or mesh, into a rasterized image or a discrete grid, which is creating bigger blocks. This helps us take out any of the tiny dust particles and instead group together clusters of depth to something real and actionable. We also find the ground plane through something called ransack, and then we find anything above that ground plane. Those are the obstacles. Now, we have several other videos on our pipeline if you're interested in how that specifically works, if you're interested in more. But the bottom line is that our mower doesn't see, in the traditional sense, images or things. It sees in depth clouds of data. Okay, that wraps us up. As always, let us know in the comments what you'd like to see us explain, how anything about our product works,